Hello class, and welcome to chapter 10, which is all about radical functions and geometry. We're going to skip over section 10.1 and go straight into section 10.2, which is about simplifying radical expressions. When you have simplified radical expressions, that means it does not contain a perfect square factor. When we're talking about a radical, that means anything underneath a square root. So for example, this right here, square root of 16 is a perfect square factor because the answer to that is 4. It does not contain any fractions, so we can't have, for example, the square root of 1/2. We would have to simplify that, so there's no fractions. And we cannot have the square root in the denominator of a fraction. So you are not allowed to have 1 over the square root of 3. You would need to go ahead and simplify that even further. One important thing to note is the perfect squares. So we've got 1, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, 4, square root of 25 is 5, etc., etc. for 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So these are the first 15 perfect square numbers. We could continue this list on infinitely, finding it by squaring a number. So these are the numbers that we are not going to be, that we're going to need to factor out in order to simplify. Two important things. Product property. So you can break a square root into the product of two factors. So just like I can say 8 is equal to 2 times 4, I can also say that the square root of 8 is equal to the square root of 2 times the square root of 4. So just like we have that value, we can break it up into different square roots. Same thing happens with the quotient. You could take the quotient and split it up into the square root of the top over the square root of the bottom. This is going to be helpful for us when we are simplifying. We also need to know how to deal with variables. There are two cases, the even cases and the odd cases. So with the even cases, you are simply taking the square root. So the square root of x squared is x. The square root of x to the 4th is x squared. The square root of x to the 6th is going to be x to the 3rd. The square root of x to the 8th is going to be x to the 4th. So all you are doing is taking that exponent and cutting it in half. When we are looking at odd square roots, so 3, 5, 7, 9, we have to take an extra step in order to be able to solve these. So we're going to split it up into the product of factors and say that x to the 3rd is x squared and x, 2 x's and 1 x. X to the 5th would be x to the 4th and x. So you're splitting it up so that it's an even number and a single x. So that even number and a single x. Then we can go ahead and solve that. So the square root of x squared is x. So simplified, the square root of x to the 3rd is x square root of x. Simplified, the square root of x to the 5th is equal to x squared and x. The square root of x to the 7th is x to the 3rd and square root of x. X to the 9th is x to the 4th, square root of x. So we take the square root that we can solve, that even value, and leave the square root of x underneath that radical symbol. Now when we're talking about simplifying, so we're looking for things that can multiply to 180. What's important here is we want to use this list. So we're looking for numbers on this list that can divide 180. So for example, I know that 180 can be divided by 9. So I'm going to split this into the square root of 9 and the square root of 20. Now I can solve the square root of 9, which is going to give me 3. I cannot solve the square root of 20, so that's going to stay underneath the square root. I now need to double check. Can 20 be divided by a perfect square? The answer to this is yes. I can split that into the square root of 4 and the square root of 5. That 3 stays out in the front because we already took the square root of 9, which is 3. So now I'm going to take the square root of 4, which I can solve, and get an answer of 2. So I've got 3 times 2, and the square root of 5 we can't solve. Then I can solve 3 times 2, which give me 6 square roots of 5. So simplified, 180 is 6 square roots of 5. Go ahead and try this one on your own. Pause the video and then start again when you're done. So we have 9 and 6 can multiply to 54, so I get 3 square roots of 6 as my simplified answer. We can also multiply to start, so I've got 14 and 2. So 14 times 2 gives me the square root of 28. Then I need to check, is there anything I can simplify with? 28 can be split into square root of 4 and square root of 7, which gives me 2 square roots of 7. Go ahead and try this one. Pause the video and start it again when you're ready. So we have square root of 50, which splits into 25 and 2, or 5 square roots of 2. Sometimes we have more complex values that involve numbers and variables. When you do this, take it piece by piece. So first I'm going to look at 90. 90 can split into 9 and 10. Then I've got an odd variable, so I can split that into an even and plain x. Then I have an even, that's going to stay put, and another odd, so I can split it into z4 and z. Now I'm going to solve all of the pieces that I possibly can. So the square root of 9 is 3. I can't solve the square root of 10. The square root of x squared is x. I can't solve x. The square root of y to the 4th is y squared. The square root of z to the 4th is z squared, and I can't solve z. So our final answer consists of all the pieces that we could square root, 3x, y squared, and z squared, and all of the pieces that we couldn't. The pieces that we couldn't stay underneath that square root symbol. The pieces that we could solve stay outside of the square root symbol. Try this one on your own, pausing the video and resuming when you are ready. So we split 32 into 16 and 2. R squared is even, so it stays. K to the 4th is even, so it stays. N to the 5th is split up into the 4th and 1. So we have all of the pieces that we can solve outside and those pieces that we couldn't solve on the inside. Then when we deal with fractions, you're going to want to split it up. Square root of 17 over square root of 9. Checking to see if we can solve either of those pieces, we can take the square root of 9 and get an answer of 3. So square root of 17 over 3. 17 can't be divided by any perfect squares, so this is our answer. It is okay to have a square root in the numerator. Try this one on your own, pausing and resuming when you are ready to go. Square root of 21 and square root of 49 splits into square root of 21 over 7. 21 can't be divided by a perfect square, so we're done. The last case that we have to worry about is when we split it up, so square root of 35 over square root of 2, and I can't solve the bottom right away. So I can't take the square root of 2. I'm also not allowed to have a square root in the bottom of my answer. In order to fix this, we're going to multiply top and bottom by the square root of 2. So up top I have the square root of 35 times the square root of 2, which is the square root of 70. On the bottom I have the square root of 2 times the square root of 2, which is the square root of 4. Now I double check to see if there is anything I can solve here. I can solve the square root of 4, which gives me an answer of 2 on the bottom. And then I have square root of 70 up top. So now we're going to go ahead and check, can 70 be divided by any of the perfect squares? It cannot, so our final answer is square root of 70 over 2. Go ahead and try this one on your own, pausing and resuming the video when you are ready to go. So we have 23 and 5, multiplying top and bottom by the square root of 5, gives you 115 and 25. We can solve the square root of 25 and get the square root of 115 over 5. Now that you are done with the video, please show your notes to the sub and get your homework worksheet.